Hi, everyone. Welcome to this office hours session on how to ensure your AWS workloads are resilient. So quick notes before we get started. This is an interactive webinar. I want to hear from you as much as you'd like to hear from me. So again, if you came with any questions, please feel free to enter them into the Q&A panel or the chat, or just hang out in the chat. Let us know where you're watching from, what brought you here today, what some of your reliability initiatives are, if you're comfortable sharing that. Again, this is interactive. We'd really like to hear from you. So don't hesitate to speak up. Also, this webinar will be recorded. The recording will be made available afterwards. And if you're new to office hours, welcome. This is a monthly series that we do on various topics within Gremlin and around reliability in general. If you'd like to see future sessions, you can always go to gremlin.com/office hours. That'll also show you our previous recordings in case you want to view those too. Also, I'm Andre Newman, Senior Reliability Specialist here at Gremlin. Nice to meet you. I'm here for you guys, so if you have any questions, comments, complaints, well, questions and comments anyways, feel free to send them anytime by posting in the chat. I'll address them throughout the session, and we'll also have time at the end for open Q&A. So let's get into it. Today, we're going to be talking about AWS resilience. Specifically, oops, I'm sorry. Apparently this agenda is a little bit off. Okay, so ignoring the agenda. Today, we're going to be talking about what resilience means on AWS, a bit of tools that AWS gives you for managing resilience within your workloads. I'll also be doing a bit of a demo to show you about how Gremlin can be used for testing AWS resilience and your AWS services. And then we'll end with a bit of time for Q&A. But again, if you have questions throughout the webinar, don't hesitate to enter them in the chat or the Q&A panel, and I'll get to them throughout the session. So I like to come up with goals during these sessions just to give us something to work towards. Yours might look similar to these. Yours were probably different. Again, if you don't mind sharing, if you came with goals that you'd like to share, feel free to enter them into the chat. But the ones that I'm going to look at today are first, I want to get a list of reliability action items for a service running on EKS, Elastic Kubernetes Service. Basically, I want a way for Gremlin to tell me that these are the things I need to work on to improve the reliability of my services. So having that in a nice list view would be really convenient. And then I'm actually going to test whether my EKS cluster is availability zone redundant. And I'm going to use what's called a black hole experiment to do that. If you've used Gremlin experiments before, which you likely have if you've been in our product, you know what they're capable of and what they can do. So I'm just going to do a really quick one that takes one of our nodes down and I'm going to ensure that our application keeps running. And again, if you came with goals and you're comfortable with sharing them, definitely let us know. Like we're all working on the same general things. We're all working on AWS reliability. So being able to share goals just kind of helps us all grow. So again, if you're comfortable with it, please feel free to share them. All right, so let's start with the basics. What does reliability on AWS really mean? Well, when talking about AWS reliability, what we're really referring to is how reliable are the workloads that you're running on AWS, not how reliable is AWS itself. AWS is rock solid, it's a great platform, but that doesn't mean that your applications and services are equally reliable. Your systems can still fail due to things like host or availability zone outages, misconfigurations, especially regarding networking and VPCs. If you're coming from an on-prem environment, especially, networking on the cloud is different. There are a lot of different rules and a lot of different configurations, and sometimes a rule slips through that we didn't catch. So these are things that we need to be concerned about. And also, as another example, there are spot instances. Now, spot instances, if you're not familiar, are more or less temporary instances that are less expensive than regular on-demand ones, but with the caveat that AWS can pull that hardware back for another use at any time. So if you use spot instances, you can save a few bucks, but you also need to set up a failover system for when this happens, like migrating your workloads. These are just three examples. There are millions of other examples that we could work off of, but this just gives you an idea of some of the challenges that you need to consider when you're working in the cloud. The good news is that AWS gives you a ton of tools for making your workloads more resilient and for tackling some of these problems. And as you're setting up those tools, Gremlin is here to help you test them and make sure that they're working as expected. So we'll see how those two kind of play together throughout the session. So pop quiz time. How many people know of or have heard about the Well-Architected Framework? While you guys are answering that, I just want to cover, reliability on AWS is a complicated topic. AWS has a million different services. Each service has a million different ways of adding resilience. Take AWS Lambda, for example, one of their first, I believe their first serverless offering. So the idea with Lambda is pretty straightforward. You just take your application's code and upload it directly to AWS, and they run it for you. Adding things like redundancy and failover is super easy. You just edit a text box that tells AWS how many copies of your code to run concurrently, and AWS takes care of the details. You can load balance between them. You can have them run in different zones. Super easy, super straightforward. Well, on the other hand, if you're using a much more complex service like EC2, where you're running your own virtual machine instances, it's a lot harder. Even if you're running the exact same code, EC2 is a much more complicated service with many more moving parts and dials, so the tools and techniques for adding redundancy are different. The good news is that AWS gives you guidance, and this is, where the pop quiz comes in. AWS gives you what's called a well-architected framework. Most major cloud providers do this, but AWS is kind of the best known. This is somewhat like a reference guide for building optimal workloads on their platform. And there are six main pillars in it. I'm not going to go over each one, but I will point out one that you probably noticed, which is reliability. And AWS, just like any cloud provider, knows that reliability is a big concern, but they know their systems better than anybody else. So this is a really useful resource for teams like yours to go into and make sure that you're building your workloads the way that AWS suggests that you should. We even use this well-architected framework when developing some of the tests that we have built into Gremlin. So I'll show you a bit more about how that works later too. Uh, and again, because I've seen folks join, if you have any questions that you'd like to ask or any comments that you'd like to make, we have our webinar chat, which is open. We also have a Q&A panel that you can submit questions into. So again, don't be shy. I'm here to answer your questions. So where exactly does Gremlin fit into this? Well, Gremlin tests your AWS services to make sure they're resilient by recreating different failure conditions. Things like broken network connections, slow dependencies, heavy disk usage, or even zone outages. The important thing is that these are fully controlled tests, so your services never actually fail, but you still get that insight into what happens if these failures actually did occur in production. The way it works is pretty straightforward. You deploy the Gremlin agent to your EKS cluster or EC2 instances, or if you're running on Lambda, you can use failure flags to deploy to your applications. If your services are running behind a load balancer, you can optionally grant Gremlin access to view your load balancer metrics and use those to create what we call health checks. And the reason this is useful is that while a test is running, Gremlin can use these health checks to automatically monitor your services and make sure that the service is still healthy and responsive. So let's say something unexpected happens, like you're testing your front-end service and it suddenly starts reporting errors. Gremlin can detect this, stop the test, and return your service to normal. Again, I'll show you what this looks like in the demo, but you can get a sense from this screenshot. Here I have my different services that are set up in Gremlin. I have them connected to my AWS account. And under that health checks column, you see that purple G and then the sort of timer looking icon. That indicates that I had Gremlin set up these health checks for me. It's looking at CloudWatch, my CloudWatch metrics, and it's keeping an eye on the service so that while I'm testing it, I can fall back safely if I need to. And so the first thing that happens after you add a service is you get what we call detected risks. This is a feature that automatically finds configuration issues in your service. And it does this by using configuration data that's already available to the Gremlin agent, so it doesn't require any additional effort from you. I mentioned earlier that, we'd like to get a list of things that we can work on. This is that first list that we get. It shows you essentially different reliability related items within the service that are relevant to your service and whether this service is at risk, meaning it's susceptible to this detected risk, or if it's mitigated, which means that it's not susceptible to it. And if you've been following this for a while, you probably noticed that we started out with Kubernetes specific ones. This is just because most of our customers use Kubernetes. It's an incredibly popular platform. And it's also something that we can pretty easily hook into to see if there are certain things that are missing that are putting your services more at risk. But we've also added risks to that are specific to AWS. And these are the ones that I really want to highlight for this session. So if you look at the screenshot, there are three in particular. First is load balancer availability zone redundancy. This just checks your ELB to make sure that's mapped to at least two availability zones, to making sure that if one of these availability zones fails, you can fail over to another working one. There's also cross-zone load balancing. This is a bit similar, but it's more focused on evenly distributing traffic across all instances in your availability zones. So once you have that AZ redundancy set up, it's just making sure that traffic is actually being distributed between them. And last is load balancer deletion protection. This is a very simple flag that just determines whether or not you can delete a load balancer. You can imagine that if you're running a service in production, like a front end to your website, and you accidentally delete the load balancer that's distributing traffic to that, that's a big problem, right? That's something that we really don't want to have happen, especially if you're using something like an infrastructure automation tool where a deletion might be just an accidental push that somebody did just without intending it. So these are the three kind of main things that we look for automatically, where as soon as you add an AWS service, these just pop up immediately and give you a quick insight into some quick wins for fixing reliability issues. One other note on this, Gremlin is smart enough to know whether or not a detected risk applies to a service. So for instance, the service in the screenshot is running on AWS, but it's not a Kubernetes service, so you only see AWS risks. I'll show you a service that is Kubernetes and also running on EKS, so you'll see both Kubernetes and AWS risks. So you don't have to worry about including or excluding specific ones or being scored incorrectly. This is all just done for you automatically. All right, and the last thing I'll cover quickly before the demo is our well-architected cloud test suite. Earlier I mentioned AWS has their well-architected framework. That's sort of your handbook for making sure that your AWS workloads are resilient. Well, we designed this test suite around many of the best practices presented in that framework and also best practices from other cloud providers. So we created a series of tests that you can run on your services. Now, where detected risks are passive, you just kind of have them displayed to you as you log into Gremlin. These are tests that actively run on your services in order to simulate failure conditions. So I'm just going to go through the test quickly. We start with redundancy, first by looking at host redundancy and availability zone redundancy. We also check DNS redundancy. So is your service reachable if one of your primary DNS providers goes offline? We all know the saying, it's always DNS. If not, you probably hear the saying sooner rather than later. We always check DNS configurations to make sure that if one of your resolvers goes down, you're able to fall back. It's a very, very common issue, but still one that we want to test for. And then when we look at scalability, we're looking at hardware scalability. So does your service remain responsive when your CPU and memory are strained? And if not, can you scale quickly enough to add the necessary resources? Similarly, we also check disk I/O or disk throughput. So if you have a service that reads and writes a lot of data to disk, like a database, how does it perform when your throughput is limited? What if AWS has a quota that's set on your disks that limits the amount of traffic that can go to them? These are things that you also want to test for to make sure your service can withstand these types of real-world scenarios. And then we also look at dependency risks. So dependencies are any other service that your service relies on. This can be another AWS service like RDS, third-party service like Gremlin, or even another service in your AWS environment managed by a different team. Let's say a different engineering team within your company that you make calls to. So we're looking for three main things. First is if a dependency like this fails, can your service withstand the failure? With latency, if a dependency doesn't fail outright but performs slower than expected, does that cascade up to your service too, or is your service able to tolerate that latency? And then there's certificate expiration. So if one of your dependencies is about to have a TLS certificate expire, so that secure traffic is about to expire, that can mean very bad things for your service, like not being able to connect or displaying errors to users. So we want to make sure that we stay ahead of those expiring certificates by actively testing for them for each of our dependencies. All right, so I know that was a whole lot that I covered quickly. Um, Again, if you guys have any questions that come up throughout the session, feel free to drop them into the chat or the Q&A panel. Happy to get to them as we go, but otherwise, I can continue with the demo. Oops, sorry, just give me one moment. All right. So for this demo, I wanted to focus more on EKS, or Elastic Kubernetes Service, mostly because a lot of our customers use Kubernetes. A lot of our customers run Kubernetes containers on AWS. So it's just a very good common baseline platform to work off of. But also, this gives you a complete overview of all the different features that are available in Gremlin for AWS and Kubernetes services like those detected risks. So I just want to start off by showing you the different services that I have running. These are all different containers running on Kubernetes in my EKS environment. As you can see, I've already kind of got them set up. Each of them has a score. Each of them has some risk associated with it and health checks. Now, in Gremlin, you can link these services to the load balancers running an AWS account. Like I was mentioning earlier, Gremlin can use your load balancers as health checks for your different services. And you can see that quickly here with this AWS account ID tag. Since I have Gremlin connected to my AWS account, it knows my account ID, it's able to see my Elastic load balancers, and it's also able to connect those to my different services. So it knows that I have a load balancer that's pointing to this ledger writer service. It makes that connection. So now whenever I run a test on the ledger writer, Gremlin automatically knows to check my CloudWatch metrics. It automatically monitors my ELB. Um, and it's able to make that connection pretty much instantaneously. You can also add your own checks, like if you have your own CloudWatch metrics, but this is just a quick and easy way to get onboarded. So let's actually take a look at what one of these services looks like the ledger writer, for example. So if you haven't seen this screen before, this is an overview of a service, gives you details about where the service is, where it's running. It also shows you its reliability score. So see, I've already ran some tests on it, some of them from past, some of them have failed. Gremlin's already given me a list of detected risks that I can click on. And I've also got a couple dependencies that the service is talking to, so I can run dependency tests on this too. So first, I'm going to click into detected risks just to see what it is that I'm at risk for. And it's a combination of things. So my load balancer cross zone isn't enabled, so I don't have traffic being distributed evenly across zones. Same thing with deletion protection. This load balancer can be deleted if I go into the AWS console. So that's a risk that I want to consider too. And then I'm also missing this Kubernetes liveness probe. Now, if I want details on any of these risks, I can just click on them and then scroll down, and Gremlin will give you a full explanation of what the risk means, what it is that Gremlin is checking, and even some suggestions on how to fix this. So in this case, I need to go edit my Kubernetes configuration and push a change. So I'm not going to worry about this right now. But again, for any of these risks, even ones that are mitigated, you can go in, click on it, and get a full description of what it is Gremlin's looking at and checking for and how you can fix it. So for now, I'm actually going to go back to my service so we can take a look at some of these tests. So again, you can see the different tests that I was talking about just a minute ago and some of the different categories that they fall under, like scalability, redundancy, and dependencies. I'm actually doing pretty good on redundancy. That's 100%. That's a great sign. But you can see with scalability, I failed the disk IO test. And if I want to find out why exactly I failed, it's pretty straightforward. I can just click on the result. It'll bring me to the most recent run, the run that gave that result. And from here, I can actually click into the different elements of this test, like this test run, and see what the actual result was, what the cause of the failure was. So it's a really good way to just dive deep and quickly see why it is that your system failed and get that insight into what you need to do to fix it. And this also makes it really easy to rerun the test in case you do implement a fix and want to test it quickly just to make sure that it's actually valid and working the way you expect it to. One last thing I'll cover before I actually run a test is those health checks that I mentioned earlier. So like I mentioned, Gremlin is able to use CloudWatch to monitor the metrics that are relevant to your service. The way that's set up is by going under settings and then health checks. And we have what are called intelligent health checks. These are automatically set up by Gremlin. They're based off of three key metrics: latency, error rate, and request weight. Um, all you need to do in order to configure these is to select the ELB in your account that is relevant to that service. So in this case, I only have one. So if I look at my AWS account, just the one comes up. I can select it and click next. And then I tell Gremlin that, yes, I want to use intelligent health checks for the service. And it just goes and takes care of that for me. And the benefit of this, again, is that when I run a test, Gremlin will monitor these metrics for me automatically. And if it notices any discrepancies, it'll stop the test, it will record its observations and let us know that it did stop the test and here's the reason why. So let's take a look at what this looks like in practice. So let's go back to, let's say, we're running a dependency test. let's go to our ledger GB dependency and rerun our certificate expiry test. So all you need to do is click run. Gremlin will start distributing the test. It will use our intelligent health checks and even show you the output right there. So you can get insight into what exactly it's doing and what exactly it's looking for. And then you can monitor the test progress as it runs. And unsurprisingly, because it failed before and I didn't make any changes, it failed again. We can go through and look and see exactly what the cause was, what the output was, and what we need to do to fix it. So again, dependencies are detected automatically. Gremlin creates these tests for each of your dependencies automatically. All you need to do is go in, enable those health checks, and then run them to get your results. So now let's say we want to run a bit more of an advanced test. We want to see what happens if we lose an entire availability zone. What does that do to our cluster, and what does that do to our application specifically? And the way we can do that, well, there are a couple of ways you can do that. First, we can run a zone redundancy test on this specific service. Because this is a specific service, the ledger writer service, this zone test will only run the zone test on this service, so it will only stop the instances of the service that are in different zones. But in this case, we want to do one for the entire cluster. So for that, we can go to experiments. This is where you can run one-off experiments, one-off fault injections, like injecting CPU consumption or terminating processes. In this case, I want to drop network traffic to a zone. So I'm going to go to new experiment. First thing Gremlin asks is, what do you want to run this experiment on? You have the option of selecting hosts, containers, or a Kubernetes cluster. In this case, I want to test the cluster itself. So I'm going to keep it selected at hosts. Further down is where you can refine your selection. So I only have 2 hosts in my environment. Each of those hosts is running different containers. You can actually hover over and see specifically which containers and which hosts those are here. Gremlin collects metadata about each of your different hosts. So in this case, I want to look for a specific availability zone. So I can go here to the zone tag and I can select either US East 2A or US East 2C, depending on the one I want to take down. Let's select 2C. Gremlin has already highlighted the host that's there. This is just a indicator of basically the scope of your experiment, what's going to be impacted by this experiment. So you can just very easily visualize which parts of your infrastructure are going to be impacted. So with that selected, I'm going to scroll down. I'll pick choose a Gremlin. Again, we want to cause a network outage, so I'm going to select network and then black hole. What this is going to do is it's going to take down traffic to this specific host, again, selected by that zone tag for 60 seconds or however long we want to configure that for. There are a few other options you can configure here. I'm not going to go into a ton of detail about them, but I would suggest either reading the docs or even just playing around with it on your own, seeing how they work and seeing what results you get back. So now I'm going to click Run Experiment. This is going to go out and this is going to essentially drop network traffic to that host that's running in that zone. And with a one-off experiment, we don't currently have health checks implemented. So in this case, I would need to go to my application and check it to make sure that it's still available and still running. I could set this up in a scenario where health checks are involved, but just for this case, I wanted to show you what it's like to quickly go in and get an experiment up and running so you can just quickly test an assumption that you have about your systems and your services. So you can then later on go on and implement those fixes. But let's say I'm done testing. I want to stop this impact. I want to return my systems back to normal. I just need to click halt. I can give a reason, like let's say confirmed my cluster is AZ redundant. Gremlin will go out to my cluster. It'll send out that halt command. The experiment will stop running, and then my network traffic will be brought right back to normal, and my systems will return right back to normal too. So again, we really make it easy to safely fall back and stop experiments, either once you're done running them, or if they don't go as planned, either using health checks or by using the big red halt button. You kind of have options there. All right, so with that all said, I'm just going to head back to our slides to wrap up. Again, we do still have time for Q&A at the end, so this isn't a total wrap up. but I just want to cover some quick things before we do. So while we wait for questions to roll in, just a few closing thoughts. Again, like I showed you, you can use Gremlin to run these one-off fault injection tests on your services or on your dependencies. Since we're on AWS, Gremlin also includes a list of AWS services to select from. We call it the providers dropdown. So if you don't remember exactly what the DNS name is for RDS running in a specific region, don't worry, we've got you covered. That includes ports as well. We've also generally put a lot of thought into making dependency testing as easy as possible. So if you ever want to test what happens if your service can't communicate with RDS or if it can't communicate with any of the other dependencies that it's talking to, you're able to easily go in, select those dependencies, and run those tests on them to make sure that your service is resilient to those. And if you haven't created a service, I highly recommend doing so. Services are a great way of just tracking the applications that are important to you and also tracking their resilience over time. So you get that really nice reliability score, but you also get that reliability score in the past. So you can see what improvements you made, or if you've had regressions and that score has gone down, you're able to see exactly when that changed and understand a bit more about why that change happened. It only takes a few seconds to set up, assuming you have the agent already running. Even if you're a new Gremlin user, you have access to this, so you can go in and check it out by going to app.gremlin.com/services. If you are brand new to Gremlin, welcome. We offer a free 30-day trial at gremlin.com/trial. You can always sign up there. That'll also give you access to the Gremlin platform, so you can try out everything that you saw in this demo. And speaking of, if you found this session useful, I'd love to see you in one of our upcoming ones. We post all of our scheduled sessions and topics at gremlin.com/office hours. All of them are free to watch. And again, I just want to stress, these are for you. So if you have questions about Gremlin, or if there's something that you're not sure about that you would like to see us demonstrate or that you'd like us to talk about, we're here for you. So always feel free to leave us suggestions on future topics, things that you might like to see, demos that you'd demos that you might like to see, and we'll make sure to include that in our rotation. And also, if you'd like to see recordings from previous sessions, gremlin.com/office hours is also a place to go check those out. So with that said, that is the webinar portion of this office hours. Again, if you have any questions at all, any topics you'd like me to bring up, anything you'd like me to go over again, please do not hesitate to put it into the chat, the Q&A panel, and I'll make sure to get to them. Otherwise, I will spend a minute or so here to wait for questions to roll in. Huh. Apparently, it was super clear because I don't see any questions coming in. Oh, in that case, while we're waiting, one more thing I will show you, since we have time, is essentially what those other detected risks look like. So let me go back to my services. Again, you see I have a few different services that are all running on EKS, but this one has a few more risks that are susceptible to. So just out of curiosity, you click on that. And what you'll see with detected risks is they cover all sorts of different best practices for each of the different platforms that you're looking at. So in the case of Kubernetes, we look at things like, do you have multiple instances of your pod running simultaneously? Are they running in different zones? Um, were you able to actually deploy the pod? Do you have like a crash loop back off or an image pull back off error that you're running into? Things that are relatively common for folks to run into when they're deploying to Kubernetes, but that are still really important to look for. So in this case, like I noticed that here it's saying I'm AZ redundant. I'm not AZ redundant. So this is a risk I need to consider. And same thing with AWS, because I'm not using AZ redundancy. This is telling me I need to go back in and fix that. Same deal for a zone redundancy test. In this case, I haven't actually ran it, so I'm not sure what my result is. But since I already have my intelligent health checks set up, I can just go in here, click run, and get that result back. And this is actually a really good use case. If Gremlin is unable to run a test for any reason, it'll tell you exactly why. In this case, my user service is only running in a single zone. So of course, it doesn't make sense for Gremlin to go take down that zone because it knows it'll be a failure. So in some cases, you'll have some work that you need to do just right off the bat just to fix reliability so that you can more thoroughly test it. Right. Well, I'm actually not seeing any questions come in, so I'm going to assume that the session was perfectly clear. Uh, if you do think of a question afterwards, not a problem. We'll have a survey at the end of this session that you can fill out. You can also reach out to us at any time by going to gremlin.com/contact. More than happy to hear from you. In the meantime, I really hope this session was helpful for you. Thanks so much for joining us today. Again, if you have questions or ideas for future topics, I'd highly encourage you to send them to us. But in the meantime, thanks for joining this today and hope you have a great rest of your week.